Imagine the vast and mysterious universe within us, a cosmos of microorganisms living in harmony, or sometimes discord, in our gut. Among these microbial residents, Akkermansia mucinifera stands out as a superstar, playing a pivotal role in maintaining gut health and bridging the gap between the gut and the brain. For children with neurodevelopmental disorders, such as attention deficit hyperactivity disorder and autism spectrum disorder, the story of Akkermansia becomes even more intriguing. Could a deficiency in this bacterium contribute to the challenges faced by these children? Let's dive into the science. The gut microbiome is an intricate ecosystem of trillions of microorganisms, residing primarily in the large intestine. These microbes are not just passive passengers. They are active participants in digestion, immune modulation, and even communication with the brain through the gut-brain axis. Akkermansia mucinifera, a keystone species, has been heralded for its ability to maintain the integrity of the gut lining and regulate inflammation. ADHD and ASD are neurodevelopmental disorders characterized by challenges in behavior, communication, and social interactions. While their exact causes remain elusive, research has increasingly pointed to a connection between these conditions and alterations in the gut microbiome, a phenomenon known as gut dysbiosis. In children with ASD, studies have consistently reported reduced levels of Akkermansia mucinifera. This bacterium thrives on the mucous lining of the gut and helps produce metabolites such as short-chain fatty acids, including butyrate, which play a critical role in maintaining gut health and influencing brain function. A deficiency in Akkermansia can compromise gut barrier integrity, leading to increased gut permeability or leaky gut. This in turn may allow pro-inflammatory molecules to enter the bloodstream and potentially impact the brain, exacerbating symptoms of autism. But it doesn't end there. SCFAs also modulate the gut-brain axis by influencing neurotransmitter synthesis, including serotonin and dopamine, which are crucial for mood regulation and behavior. Children with ASD often exhibit imbalances in these neurotransmitters, raising the possibility that gut dysbiosis, including Akkermansia deficiency, might be a contributing factor. The story of Akkermansia in ADHD is still unfolding, but early findings are compelling. ADHD, characterized by inattention, hyperactivity, and impulsivity, has also been linked to gut microbiome imbalances. While fewer studies have explicitly focused on Akkermansia in ADHD, broader research suggests that gut dysbiosis can influence brain function by altering the production of neurotransmitters and immune signaling molecules. One hypothesis is that a reduction in Akkermansia may impair the gut's ability to produce critical metabolites, which could influence brain activity and behavior. For example, the inflammation resulting from a compromised gut barrier may affect neural circuits involved in attention and impulse control. The modern diet and environmental exposures may also play a significant role in the gut-brain connection, particularly in children with ADHD and ASD. Exposure to pesticides, such as organophosphates, has been linked to neurodevelopmental disorders, including ADHD and ASD. These chemicals can disrupt the microbiome by reducing microbial diversity and impairing beneficial bacteria like Akkermansia mucinifila, which can be taken orally via pendulum therapeutics. Moreover, organophosphates can interfere with the production of acetylcholine, a neurotransmitter crucial for attention and learning, further compounding the challenges faced by children with ADHD and ASD. Ultra-processed foods are a staple of modern diets but are detrimental to gut health. High in refined sugars, unhealthy fats, and artificial additives, these foods promote inflammation and negatively impact gut microbiota composition. Excessive sugar intake can feed harmful bacteria while starving beneficial species like Akkermansia. Additionally, artificial emulsifiers and preservatives in ultra-processed foods may erode the gut lining, exacerbating gut permeability and systemic inflammation. The interplay between these environmental factors and microbiome health underscores the importance of dietary and lifestyle interventions for children with ADHD and ASD. Avoiding pesticide-laden foods and reducing ultra-processed food consumption can help restore microbial balance and support gut-brain health. A deficiency in Akkermansia mucinifila is not just a marker of gut dysbiosis. It's a potential driver of systemic changes that ripple across the body and mind. Here are some key mechanisms. Increased gut permeability. Low levels of Akkermansia weaken the mucus layer that protects the gut lining. This can lead to increased gut permeability, allowing inflammatory molecules to enter the bloodstream and potentially trigger neuroinflammation. Reduced SCFA production. Akkermansia contributes to the production of short-chain fatty acids, which support brain health by reducing oxidative stress and modulating inflammation. Immune dysregulation. The gut microbiome influences the immune system, and an imbalance can lead to chronic low-grade inflammation, which has been implicated in both ADHD and ASD. Given its importance, researchers are exploring ways to restore Akkermansia mucinifila levels in children with ADHD and ASD. Strategies include dietary interventions, prebiotic fibers such as inulin and oligofructose can nourish Akkermansia and promote its growth. Foods like garlic, onions, and asparagus are rich in these fibers. Probiotic supplements. Although direct Akkermansia probiotics are still in development, early trials show promise for improving gut health and reducing inflammation. Lifestyle factors. Exercise and stress management may indirectly support Akkermansia by promoting overall gut microbiome diversity. The connection between Akkermansia mucinifila and neurodevelopmental disorders opens exciting avenues for therapeutic interventions. However, it's essential to approach this field with scientific rigor. While preliminary studies are promising, larger, well-controlled trials are needed to establish causal relationships and evaluate the efficacy of interventions. Moreover, clinicians and parents should exercise caution before adopting unproven treatments. The gut microbiome is a complex ecosystem, and interventions targeting one species must consider the broader microbial community. In the grand cosmic dance of our microbiome, Akkermansia mucinifila plays a leading role, especially in the context of ADHD and autism spectrum disorder. While we are only beginning to uncover the intricacies of this relationship, the evidence so far suggests that nurturing a healthy gut microbiome may hold the key to improving the lives of children with these conditions. As we venture deeper into this microbial universe, one thing becomes clear. The gut and brain are not isolated systems, but interconnected galaxies, influencing and shaping each other in profound ways. By understanding and harnessing the power of Akkermansia, we can illuminate new pathways to health and well-being for children with ADHD and ASD. Thank you for watching. For more information, please visit our website.